Um, hey guys, nice to be back here again among friends. Sorry that we couldn't meet each other in person, COVID and whatnot. Um, well, I'm here to present the paper on conversational AI-enabled user interfaces for HPC and HPC tools. So, of late, let's say conversational AI systems like ChatGPT are very popular. I'm pretty sure that all of you would have heard the news about ChatGPT 3, ChatGPT 4. There are also other instances of folks kind of going off that technology and creating what is called as domain specific, maybe ChatGPT. So, did you guys hear about the Bloomberg GPT or this Wolfram GPT that was in the news a few days ago?
I certainly did, yes.
Okay, cool. And thanks for responding, Phil. Guys, let's make this a dialogue, not a monologue. I'm pretty sure that all of us can talk for, let's say, hours on and on the stuff that we work. But if you have questions, feel free to interrupt me and talk. It'll make things more fun. So at a high level, before I go into my slides, what we tried to do before ChatGPT became a thing, we read this like an almost a year ago. What we tried to do was, can we create such conversational systems for high performance computing? And just like Bloomberg and Wolfram and others realized, ChatGPT need not be best for domain specific processing. Okay. And why is that so? That's primarily because of all the terminologies and all the inbuilt knowledge that each domain has, which a standard English language dataset may not have. So when a bunch of computer geeks talk, L2 cache, L3, GPU, CPU, NIC, smart NIC, DPUs, all of these acronyms will kind of fly around the park, right? But if you look at a standard English language dataset, none of these things would appear. So there is a need for a domain specific, let's say, conversational AI system, which is capable of tackling the challenges that the HPC domain poses. Okay. So with it is with that broad goal that we were embarked on this. And the first work that we tried to do was with let's say a performance analysis tools. And all of us know that performance analysis tools are very commonly used in HPC systems, and they are essential components of it. Now, if you look at performance analysis tools, they are extremely extensive, and consequently, there is a steep learning curve in, let's say, for a person to start using it and start understanding it. For people who have been in the HPC domain for a few decades, this is not a big deal. But of late, we've been seeing a lot of non-traditional computer science users enter into the domain of computer science primarily because of the advent of deep learning. So you see a lot of data scientists, domain scientists, for instance, like medical doctors or pathologists entering the field of HPC to train a lot of models. For these kind of folks, things become very challenging if you want to move from their domain to like a keyboard and mouse and a Unix terminal kind of a domain. So one of the things my colleagues at the Ohio Supercomputing Center asked was that, hey, okay, I'm a huge Star Wars, Star Trek fan. Okay, so if you guys don't understand this video, sorry about that. So when I grew up watching Star Wars. I'm hoping that this will play. Um, so this is the scene. Okay, can you guys hear the audio?
No, we cannot.
Oh, we cannot hear the audio. Okay. How do I share it so that I also share the audio? Share share content. Share computer audio. Okay, share. So this is the initial scene where Commander Riker walks on board the Enterprise.
Data. I understand he's somewhere on this deck.
Place, sir. Must be new to these Galaxy-class starships, sir. Tell me the location of Commander Data. Lieutenant Commander Data, now located in holodeck area 4J. As you can see, sir, it's pointing you that way. Welcome, sir.
So what one of my friends told me is that, hey, uh, all the world seems to be moving in this direction. Why is still HPC stuck kind of in the Stone Ages where we still have to use a keyboard and a mouse. Say, hey, I have nothing against a keyboard and a mouse, that's perfectly fine. But is there something that will give us more productivity, more usability, and will help us kind of traverse a lot of mundane exercises to get to the crux of the solution? So we are hoping that this conversational AI interface is able to alleviate this steep learning curve and increase the productivity of novice and expert users alike to use the system. So visually, this is typically how we use, let's say, the state-of-the-art HPC middleware and programming tools. What we want to do is propose a conversational interface, both speech and text, to access these different tools so that we are able to get to the crux of the problem, or we are able to get to the insights quicker. So this is what we are trying to solve. And in order to get here, there are a few challenges that we need to address. So as I mentioned earlier, existing like NLP, natural language processing, or automatic speech recognition systems, while they are pretty good for, let's say, conversational English, they lack a lot of domain-specific terminologies. And this makes their ability to be adapted to specific domains like a pretty big challenge. So we need to kind of retrain these models on HPC specific data sets, which by the way did not exist at the time we were working on this. So we had to create those data sets ourselves. So these were the various challenges that we were trying to tackle. And finally, once you have a data set to retrain existing models, how can you create an end-to-end system which is able to, let's say, deliver this kind of benefits to end users? So that is what we are trying to create, and this kind of shows the overall view of our software stack. So you have end users at the top who would potentially use text or speech queries. This would be piped through our let's say retrained ASR, which is automatic speech recognition, or natural language understanding models. We would then convert these intents into appropriate commands through interfaces that we created for conversational AI tools. And finally, we would show the result to the end users as well. So the first job we had to do was to create the actual HPC dataset for text and speech. So we created a bunch of basic queries. We labeled their slots and intents. So we use a lot of synonyms in HPC. So for instance, if I want to do a reduction operation, I could say, hey, do a reduce, do an all reduce, do reduction, things like that, right? So we need to make sure that we capture all of those synonyms. And we used all of these, let's say, uh, terminologies and created multiple data sets with multiple profiling intents. So intent to find out the node utilization, network utilization, process utilization, and various statistics. So we created all of these, and what we did was we ended up retraining. We basically used a process called transfer learning to pick up a trained model and let's say retrain that with some HPC specific data sets. One thing that we did was to make sure that we were able to handle various accents properly. So we also used what is called as a TIMIT dataset to support diverse accents. And we used the wave-to-vec model and speech-text model for ASR. And we used two different transformer-based models for NLU, which is stack propagation and joint BERT. So overall, the way our model would work is that whether it is a speech or text, let's say if you are talking to the interface, uh, it would be passed through the ASR model to kind of get it converted into some intents and slots. That would then get passed through your NLU model, which is the natural language understanding model, to convert them into a set of commands that the end interface would understand. These commands would then be passed to the HPC tools through the interface for conversational AI that we created. So in this particular instance, we were using the OSU INAM profiling tool to integrate this conversational AI agent. So here, what we would do was to generate different kind of URLs, and we chose URLs because OSU INAM uses different It's a web-based tool and uses different URLs to show different results to the end users. But we believe that the same would be applicable to any HPC tool. So the modification needed to the tool was as follows. So the tool needs to record the voice and send it to the conversational AI interface. And it would receive and redirect the response URLs to the corresponding web pages. So here, absolutely no changes are required. So the web UI generator would then adjust the values, and finally it will generate the query and show the result to the user. So overall, the changes required to the tool itself was fairly minimal. And now let's move on to the performance evaluation. So as you know, inference can happen both on a server as well as on an end device. So we wanted to make sure the performance was good on both. So we took examples of server class systems like these on top, and like end user systems like the ones that you have on bottom. And these are the characteristics and the various parameters of these systems. So what we saw overall was that by retraining and using transfer learning, we were used to improve the accuracy of the existing models significantly. This graph shows the overall improvement that we were able to obtain in terms of word error rate and accuracy. So as you can see, we are able to quite accurately identify the queries that the various users had posed. So we were able to reduce the word error rate, which is basically the inaccuracy, so to speak, significantly for the various text and speech queries that the end user gave. So now we move on to the evaluation for the natural language understanding portion. So here we were looking at two different models, joint BERT and stack propagation. So overall, we saw that the joint BERT model gave much better F1 scores and much better intent accuracy. So basically, this number shows how accurately the model was able to predict or identify the intent of the user. So as you can see, like we have like pretty good accuracy here. So now we are trying to put both systems together, as we mentioned. So if you are talking to the system, you will have an automatic speech recognition component first and a natural language understanding component second. And this is kind of depicting the accuracy for both systems combined. So with the speech to text ASR model, we were able to get about 92.9% accuracy in predicting the content of the users. And this kind of shows the end-to-end latency for, let's say, the system to respond in terms of seconds, and with increasing complexity of users' query. So the graph here indicates the number of words in the user's query and the time to process all of those queries. For a text-based query, it's pretty fast, but for a speech-based query, as the number of words increases, the time for processing also kind of increases. But as you can see, the overall time is still less than a second, which is fairly quick in terms of usability. So with wave to wake, we got pretty good accuracy, but it was not as good as we saw with the speech to text model. So with this, I'd like to show you a demo of the entire tool working. So this is the conversational AI interface working with the OSU INAM tool. So here we are showing how the system would work when you do like a text-based query. So let's watch that video.
Hello everyone. OSU INM is a holistic online communication profiling tool for HPC. We developed a conversational AI interface CAI for OSU INM. In this demo, I'm going to use text conversational interface to get results for two different queries. Let me start the demo by giving my first query. After executing this query, I can click on the Inference Steps button to see how CAI used natural language understanding model to understand my query and convert it to a dictionary. I can get my results by clicking on the Visualize button. So now I can see the topology of my network. Let me give a different kind of a query. I have a job running on this cluster and I want to see the CPU utilization for that job. I can directly click on the Visualize button to get my results. So now I can see the CPU usage, virtual memory uses, and the debug for my job ID. So in this demo, I showed how one can easily interact with OSU INAM using conversational AI interface.
So this was our first effort at creating a So this was our first effort at creating a conversational interface. So after this, we did some more work. As you may imagine, it is just not the let's say the obtaining the insights that matter, but in several cases, whoops, did I get stuck? No. In several cases, making sure that the user is able to properly demo or properly use a particular, let's say, system also makes a difference. So this is a subsequent updated version of the tool that we made. I hope this video is visible to you. So here we are showing a newer version of the tool, which allows you to kind of do end-to-end orchestration of jobs. So
this is a demo for a speech assistant interface / conversational AI agent through Open On Demand. Once logged into Open On Demand, you can navigate to the app, and once opened, you will be greeted with a chatbot interface where you can either type into the chat box or you can use the microphone icon in order to talk. In this demo, we are going to use the speech. In order to use it, you just click the microphone button and then tell it what you want it to do. In this case, run all reduce on 4 nodes with 8 ppn. Once clicking it for the second time, they'll send the query and ask you if you want to change any values. In this case, we're going to say no. Now that we see that all required dependencies are given, it's going to install all the dependencies required for the job, and it's going to submit it and run it. You can see all this happening in the Jobs tab. If there was stuff that we needed to install, we would see it in this installing column. If it was queued waiting for resources, we would see it in this queued column. And if it was running, we'd see it in the running column. Since this was a short benchmark, it's already done. As you can see, you can go into any of your past ones and open them also. For the most recent one that we run, we can see the output log from the benchmark, and by clicking the SBatch button, we can see the SBatch that was generated in order to run all of this.
So this is the current version of the tool, which we are hoping to develop and make available to the community shortly. So as part of this work, we explored the challenges for designing a conversational AI, or basically text or speech-based interface for HPC tools. We used state-of-the-art AI models for speech and text and adapted to it to use in HPC domain by retraining them on specific data sets that we had created. So over this talk, and this was also like a publication at ISC last year, and we have a paper at ISC this year as well, and it will be presented in Hamburg, Germany in May. So we were able to demonstrate that the interface is able to deliver higher accuracy, and we also showed that we have this end-to-end system working for not only introspecting jobs, but also the end-to-end workflow that typically users have to go through when using HPC systems, like launching a job, installing the dependencies, making sure all the packages are downloaded, and looking at the final output files. So as future work, we plan to make all these solutions available to the community. There's one request that we have. So we have this user survey. So one of the questions that we always get is, hey, why? Why do you do this? What is the real utilization for this? So we want to get a feel for it from the communities to say, to basically gauge if what we are doing here is kind of useful for the end community as well as the users. So it'll be great if you guys could take the survey. And with that, I'll stop my presentation. Thank you for the patient listening, and let me know if you have any questions.
We have a question on chat from Vladimir.
Okay, so Vladimir asks, have you considered NVIDIA Riva for ASR? But here it seems that 80% of the work was polishing the dataset. Thanks. So yes, we have considered NVIDIA Riva, but being in academia and not having money, that becomes a challenge. So Riva, you can use it to the best of my knowledge. Please correct me if I'm wrong. We did check Riva out. It was a product that you could try out for some time and then you had to pay for it. So we were trying to see if we could do it ourselves and do it better. Yes, the work was polishing the data set. So we fundamentally did not create newer models. The models are pretty good and they do exist. The problem with the models was that they were just not trained on the kind of speech or let's say words that would be used on certain specific domains like HPC. So we were creating, not just polishing the dataset, we were recreating new datasets for the HPC domain and then retraining and using transfer learning on existing ASR and NLU models. I hope that answers the question.
Does anyone have any follow-up questions or other questions for Hari? Okay, Hari, thank you very much. I enjoyed the talk a lot. Thank you.
Sure. Thanks, Phil.